So, hey everybody, my name is Raul Kripalani, and I'm gonna talk about IPC and specifically how IPC can power a new universe of L2 networks that need to exist on Filecoin for Filecoin to deliver true utility to the world. And I'll go into this in a second, and I'll show you what those networks are. But before, this is the agenda for today. First of all, I'm gonna do kind of like a very gentle introduction to interplanetary consensus. And IPC stands for Interplanetary Consensus. Why IPC for Filecoin L2 networks? I'll cover kind of like, the main thinking, the arguments, like why this is a direction that we should look at as a community. I'm also going to do a little bit of blueprinting or imagining, kind of like playing a little bit of a game here of like taking some of these networks that I think personally should exist in at least like starting literally this year. We should be seeing like 2 or 3 of these networks emerge on Filecoin. And I'm going to kind of like deep dive into some of them and outline some of the key ideas of potentially how you could use IPC to deliver those networks and why IPC is, an optimal substrate for those. And then I'll leave some time for Q&A at the end. Right. So just to start, IPC is a framework to build massively scalable custom networks. And kind of like the backend goals here is it aims to unlock planetary level performance for Web3, aims to deliver frictionless developer experiences over time. I'll go into that in a second. And it aims to power a new generation of apps that over time we hope will break Web2 limits. From the perspective of a Web2 developer coming into Web3, this is basically what you see. You start kind of like, you come from a world where you know about cloud concepts, where you know about typical scalability and like, cloud architectures and frameworks that exist that are super nice that kind of like hide away many of those details. And in contrast, you come into Web3 and start scratching the surface, and this is what you see, right? You see a massive hairball of foreign concepts that have no relationship to Web2, and they are just concepts that exist in Web3 and are really hard to approach, right? So even as a developer, when you want to build something on Web3, you end up having to understand and unpack many of these concepts at different layers to then make choices about the stack that you're going to be building on, right? And we think this is very, very broken. Especially, as I said, for Web2 developers coming into Web3, this is what they used to, right? They used to, and we all have worked in these contexts, so we can really relate to this. You have your cloud infrastructure, and then like kind of like that defines the platform where you can run a lot of these workloads. And then you have really nice frameworks that have emerged in the last decade that abstract away many of the complexities of operating software on these platforms. We've got Vercel, Firebase, Cloudflare Workers, and a bunch of things there that utilize those platforms to like make it really easy and approachable for devs to spin up and build stuff really quickly on Web2. And these are some of the features that Web2 delivers and like that make the massive scalability that Web2 is able to achieve with the nice developer experience possible. So all of this is able to power levels of scale. This is just a diagram. Juan uses it a lot, so I just copied it from him. But this is like, we're looking at 2019, we're looking at billions of transactions per second. This is just gonna grow. And if Web3 is going to deliver on its promise of building, of serving as a substrate of a new generation of decentralized consumer applications, then it needs to be able to cater for these levels of scale. So now, IPC. What is IPC? What are the key concepts in IPC? Subnets are the key unit of abstraction in IPC. So when you hear about IPC, the first thing that you're going to be hearing is IPC, build your own subnet, create a subnet, or start your own subnet topology or hierarchy, right? So we think of subnets as kind of like this key unit of abstraction that bridges Web2 and Web3 because they enable scalability both horizontally and vertically. And I'll go into that in a second. So subnets are cheap to create. They, as I said, enable all kinds of scalability. We are building the stack so that subnets are a living entity. Conversely to, for example, rollups and other chains and Validiums and kind of like the whole like ecosystem of different scaling solutions that exist in other ecosystems, those networks tend to be things that developers and a group of people that are going to be running infrastructure need to agree on and get together to launch one of these networks. So when you want to launch a new rollup, you have to recruit infrastructure providers. You need to, not providers, or you need to recruit the infrastructure. You need to recruit participants, validators, and so on. It's really hard to bootstrap one of these networks. And the goal with IPC is that you can bootstrap a network programmatically, right? So this is already built. You can literally make a call to a contract that will start a new network. It will spin up the definition of that network. And of course, the stack will need to facilitate kind of like validators congregating around that network to actually go and validate that network. But subnets are super cheap to create, and they can have ephemeral lifetime. So we build the stack to be programmable. So you should be able to spin up and spin down a subnet without having to involve humans. The subnet itself can take the decision to self-destruct at one point in time, right? Subnets allow you to define, so there's different ways in which you can arrange subnets, and every subnet can have a policy to let validators come in, and basically they can gate membership, right? And this, you can use a policy like, where is this validator located? You can use geographical, like some proof of location, for example, to grant access to a particular subnet for validation. Or you can use latency or quality of service measurements or a bunch of other things. IPC also provides a really nice framework for unified cross-net communication and value transfer between these subnets. So usually when you look at other ecosystems, there's great massive emergence of solutions, of L2 solutions there. They don't interoperate with one another under a single substrate, right? So IPC does provide that substrate for subnets under a hierarchy to be able to interoperate and communicate with one another. Now, every subnet can, and I'll go into this in a second, every subnet can be hyper-specialized. So you can customize a lot of things about it today and even more in the future. So some of those things that you can customize today are logic, the logic that is going to run. So in form of actors, in form of smart contracts. You can customize the state tree, you can customize the account model, and you can customize the syscalls and kind of like the functions that are available to smart contracts to invoke, and a bunch of other things. And also IPC is partition tolerant, and I'll go into this in a second as well. So you can envision IPC as being this framework that allows any subnet topologies to emerge where subnets can be different things. So they can represent applications, they can represent infrastructural services, they can represent geographies. So just to kind of like touch on, like give a high level overview and a bird's eye view of how a lot of this works. Imagine that when you start a network on IPC, you don't start just a network, you start a topology, which you start a given subnet that then can evolve and spin up more subnets underneath it, and the tree deepens as this happens, right? So IPC is not an L2 framework, it's an infinite recursion framework, right? You can spin up any number of subnets and you can deepen the tree, and IPC interconnects all of these through parent-child relationships, with which every subnet inherits the economic security of the parent. And of course, one thing that you have to think about is as you deepen the tree, the economic guarantee is also weakened. So there's a number of things that we're looking into to sustain those guarantees as the tree deepens. But another thing that's worth mentioning here is all of these networks, all of these subnets can communicate with one another up the tree and down the tree. And then the tree can also, at the top, can also have other hierarchies rooted under it. So just touching on a few concepts here of how all of this works, you've got interactions that go up the tree and interactions that go down the tree. So those are bottom-up interactions. You've got calls, messages, receipts. You can withdraw and deposit funds between these subnets. When you start a subnet, you deposit collateral at the parent, and that collateral secures the consensus of the child. You also define a set of validator policies and weights and so on. So you define who's able to join that subnet. And you can even define things like the supply kind, which I'll go into in a second. Cool. So just to give you a little nugget of history, IPC was actually initially called Hierarchical Consensus, and it was originally developed by Consensus Lab, and we're taking this technology and evolving it even further. Cool. So as I mentioned, IPC subnets you can use the IPC framework to create all kinds of subnets. They can be application-specific subnets. These can be infrastructure services, geographical regions, and these can speak to each other. Now, I'm going to go into two scaling patterns that are possible with IPC and why you should really care about those. On the one hand, we've got horizontal scaling. So imagine that at a given point in time, your subnet is experiencing a lot of an increased volume, and you want to spin out new subnets at that level to basically scale horizontally and be able to cater for that incoming volume, right? That's something that you can do with IPC, where of course improving the experience around this. IPC is programmable. You should be able to do it. The client does not support this like really fluid pattern yet, so I want to caveat that. But this is something that we're shooting towards. And why would you want to do that? You might want to scale throughput and resources at a particular level. You might want to shard activity in an application by some partitioning criteria, or you might want to splinter operations by region, latency, so that a particular subnet, when you start seeing kind of like the validation times degrade because there are validators joining from different geographies and kind of like the latencies are, increasing over time, you could potentially take the decision to splinter that subnet, react to what's happening, splinter that subnet, and do some kind of mitosis to create two different subnets that regroups validators that are capable of sustaining specific latencies, right? Vertical scaling is all about recursion. So L3s, want to preface this with the fact that L3s are currently unstable and behind a feature flag in IPC. So if you go and experiment with IPC, you won't be able to deploy L3s out of the box yet. But the whole idea here is that given a subnet, you can fan out children on that subnet and keep increasing the depth. And why would you want to do that? Imagine that you've got a subnet that acts like kind of like the anchoring point for a particular application or the controller for a particular application. And maybe a subnet is needing to create, like it's servicing a new class of users or a new class of resources, or for example, if it's a game, it might want to create a new subnet to represent a game session, right? And that subnet can be ephemeral. So because the entire hierarchy would be secured by the economic security that is deposited, the collateral that's deposited at this level, then you get the whole subnet hierarchy inherits that economic security, right? So vertical scaling and recursion is like a really nice pattern that you'd use if you're deploying regional topologies, for example, right? So you can start with a subnet that represents a continent, and then as you start seeing validators joining and users joining in that continent, and like there's an emerging entropy and variety of latencies emerging there, you can then divide by countries and deepen the tree and have a subnet that represents a continent, and then under it, it's got its countries, and then you can even go further as the population increases in each of these subnets. So I mentioned ephemeral subnets. So the goal of IPC is that one of the goals of IPC is for subnets to be really cheap to create and really cheap to spin up and spin down. So they could be an event defined by a smart contract, by a program running on any of these chains that decides, hey, it's time to create a new subnet, right? And the subnet is going to live for 1 month or 2 days or minutes, right? So what could those ephemeral subnets be? They could be things like game sessions, compute jobs. So if you've got a compute platform, you can create a subnet to represent a compute job that is going to run for a specific allocation of time on GPUs that the network hosts, right? And it might have a time-boxed lifetime of 1 hour. After that, it is going to self-destroy. Self-destruction is not implemented yet. So I'm talking like I'm combining, reality with vision here. So bear with me. I want to give you a sense of where we headed as well with IPC, and also want to make sure that like these ideas pique your interest so that you come speak to us and tell us which ones are really important for your use cases, right? So ephemeral subnets are actually the basis for elasticity, right? If you look at other L2 solutions like rollups and so on, once you launch a rollup is designed to be static in time. Like the moment that you launch it, it would be a terrible event for that rollup to disappear, right? Unless it's, a managed operation or whatever of some kind, right? But it would be traumatic, whereas subnets are meant to be spun up and spun down ephemerally. So one thing that for this to actually become a true reality, we need to really work on the experience of how the creation of a subnet is announced, and how validators would flock to start validating that other subnet in addition to the original subnet, right? So there's, some work around client architecture involved here as well, in terms of a single client should be able to validate multiple subnets at once, right? Start and cease validating those subnets. Cool. So I mentioned earlier, IPC allows you to gate membership into any subnet, and you can define a custom policy, and you can use things like, for example, proof of location or internet location by IP or BGP route, autonomous system, latencies, and so on. So one key aspect of IPC is that every subnet is highly customizable at every level. And a lot of this relies on FEM and the existing runtimes that FEM offers. So starting from the fact that all of these subnets automatically benefit, thanks to the fact that they use FEM, they automatically benefit from all runtimes that exist on the FEM, which currently today is the EVM runtime and the WASM runtime for built-in actors, not for user-deployed actors. This allows you to, like in many cases, we see IPC really catering towards the DeepIN ecosystem and other verticals like gaming and social and so on. And more often than not, these networks don't actually need they don't want users to deploy custom contracts. They have embedded logic. They have logic that represents that application. They want to evolve that logic over time, right? So there might be some governance involved in upgrades and so on, but they usually have some very tight logic that they want to run that represents the application. Other ecosystems call this app chains, right? So you can think of subnets as being really app chains that are deeply specialized in what they do. And for that, they use the FEM, which as said offers the EVM runtime, but also you can deploy WASM actors today as built-in actors. And in the future, you could have user-deployed WASM actors as well, if that's important. It is in the roadmap, in the long-term roadmap of the FEM. So we really want to force this like rethinking of what runs on chain, right? The goal of IPC is to enable you to have as much activity as you need on chain. So you should never really feel limited by what can go on chain and what can't in terms of scale, right? So that's where the framework really accommodates all these scaling patterns horizontally and vertically and also elastically to enable you to kind of like run any kind of program that is going to accept any number of transactions over time. And when that overflows a network, you create a new network, right? So you can also restrict user program deployments and escape to native land via custom syscalls. This is part of the architecture of the FEM. And you can also bring your own runtime. Over time, we will want to customize a lot more things about a subnet, things like consensus, the consensus algorithm, the chain schema, the transaction schema, the mempool heuristics, and a bunch of other things going forward, right? So just to give you like a sneak peek into, or like a high-level overview of general message passing, you've got top-down messages and bottom-up messages. So top-down messages are the ones that flow from the top to the bottom, from the parent to the child. And a subnet here can communicate with a subnet here by following a bottom-up route and then reversing here at the common ancestor and then becoming top-down. Another thing that children networks do is they observe the parent finality, and they use this as a driver to like situational know where they are in terms to the parent, and also to receive configuration changes and a bunch of other things. So similarly, you've got the bottom-up interactions. You've got, of course, messages, but also checkpoints. So periodically, every subnet is submitting checkpoints to the parent. With it, it's sending any messages that it wants to send up the hierarchy, And it's also informing of some things like the circulating supply and a bunch of other things as well, and confirming configuration changes. Cool. So I mentioned earlier, IPC is built to be partition tolerant, and this is based on the interplanetary principle, which is basically a principle that we like to follow. And the whole idea is that if you design systems such that they could cater to interactions between Earth and the Moon, for example, you'll end up creating architectures that can even serve cases where systems become disconnected on Earth, right? So it's a good principle to have in mind, not necessarily because we want to launch IPC subnets in Mars today, but because it's a good design principle that from which a partition tolerance emanates. Cool. So I just wanted to give you a sneak peek as well into 4 features that we've launched recently on IPC that was super important for Fluence as well, which I'll talk about, and you'll hear from them in a few hours as well. Fluence, by the way, is the first network that is the first DeepIN that is adopting IPC for its mainnet. And I just wanted to give you a sneak peek because I think they're going to be important as well for the kinds of things that I want to propose for Filecoin here on IPC. So first of all, we landed a few weeks ago. We landed a feature that allows you to take a token that is hosted on any other L1 that is not the root L1 of the hierarchy. So this could be Ethereum, Polygon, and so on. Very often people launch tokens there. And very often people want to launch they want to launch networks that have their own crypto econ, right? So IPC should allow users to create their own crypto econ, right? And their own tokenomics. So in many cases, users will want to launch the tokens in other networks, but have them move to an IPC subnet in a single step. And you don't want this to be a series of steps where the user is forced to sign 3 transactions in a row, right? So we landed a flow that uses Axelar. That's what we have these days, state-of-the-art bridge. It is a bridge though, so beware. But that's what we have these days. And we use basically with a single atomic step, a user can take a token from Ethereum or Polygon and move it into an L2 that is rooted on Filecoin and minted a circulating supply, right? So Fluence is using this because they launched their token on Ethereum, FLT, and their subnet uses FLT as circulating supply. But it's not represented as a token there. It's represented as the native coin because we mint it as native circulating supply. And this flow facilitates that in a single step. Another thing that we launched is linked tokens. So this is a set of contracts that you deploy at the parent and the child. And basically you get a token replica at the child that interacts with the parent so you can move liquidity around. And Fluence, for example, is using this to bring USDC into the subnet. Because in their network, they pay for compute jobs using USDC. And stemming from a lot of this, we also introduced token supply networks. So 2 months ago, the kinds of networks that you'd be able to create with IPC were native supply networks. So they inherited the root coin, the coin of the root chain, and now you can have any token become the circulating supply of the network. So of the subnet. So you basically, when you construct the subnet, you just provide the ERC20 address of the token at the parent. And whenever you deposit or withdraw, it's just going to transparently lock the tokens and mint the circulating supply, or burn the circulating supply and release the tokens in the parent. We also added a feature. This was kind of like a latent feature that we had there, and we kind of made it more robust so that we can actually start using it. Is the IPLD resolver. This is very cool. I think Steb will appreciate this one here. So it's a protocol and a component to achieve off-band agreements between network participants. So basically, you've got validators in a network. They are able to make observations about specific things and to agree in a quorum and to produce quorum signatures over that evidence. And if that evidence is, for example, a CID, right? Validators can confirm and attest that they have a particular CID available in the store, in the state, or whatever, or off-chain. but they know about a particular CID. The moment that you disseminate that signature, other nodes that receive it, if they don't have that CID, they will resolve it from that node automatically. So this is where the resolution comes in. We use Bitswap for that. And we also rely on GossipSub. And why is this important for IPC? IPC uses this. Subnet uses this to agree, for validators to agree on the observed state at the parent. So as you make progress in a subnet, you're always importing finality from the parent, and you don't want to get in a situation where the validator that's selected makes a finality choice that the children cannot agree on because they don't see the same height from the parent, because currently we're using hosted RPCs. The idea is to move to light clients to observe the parent chain, but it is entirely possible that behind a hosted endpoint you might have many different nodes that are load balanced. They do not have perfect synchrony between them. So, or some nodes in the some validators might be behind in the chain, or they might have gone offline in the startup, and their view of the parent is different. So you really want to make choices here that are going to get large agreement from the quorum, and this is how IPC uses the IPLD resolver. And I know that other teams are using this component as well, like Tableland, and they're using this component and protocol to actually do very cool things that hopefully you'll be able to learn about soon. Cool. So I just wanted to touch on Fluence and interplanetary consensus there. As I said earlier, this is the first DeepIn network that is launching on IPC, and we're very excited about that. We've been working very closely with them for the last 3 months, and hopefully everything will go well in the next months. Cool. So changing context, or kind of moving on the conversation a little bit from IPC itself into why IPC for Filecoin specifically. I just wanted to first touch on kind of the master plan, the Filecoin master plan that Juan likes to show. And basically IPC fits in as one of the key elements that enables step 3 to happen, right? So bringing compute to the data, not just compute, but all kinds of services, as you see in a second. Compute, in itself, the workloads of compute are very different to the workloads of an L1 chain, right? So you will want a different network. What is going to facilitate the creation of that network? IPC. So just a few ideas. I was kind of doing a little bit of brainstorming on what I personally think would be valuable for Filecoin to host going forward, and to have on top of it, to bring utility to the vast amount of data that's actually stored on Filecoin. So a lot of us have talked a lot about kind of some of these concepts, and I know we've had workshops around aggregators and hot storage layers and a bunch of other things, and of course Saturn is a really good example of a CDN. All of these things are services that need to exist on the basic infrastructure that Filecoin provides for Filecoin to really demonstrate its true utility. And so I'll just go through some of these. We've got aggregators. So take a small piece of data and bundle it into a larger deal that is acceptable by Filecoin storage providers, right? Hot storage layer. So write data to one particular point that is, replicated, load balanced, decentralized, and have it eventually flush to Filecoin cold storage, right? And have that as a buffer that is super fluid and exposes a number of front-end interfaces that allow different kinds of programs, whether they're Web2 programs or Web3 programs, to interact with those. Compute networks, we've got Fluence, CDNs, we've got Saturn, and other things that could emerge there. SP collectives, this is an interesting one. I think there is an interesting opportunity here for SPs to form coalitions that can provide services together, right? And these could be powered by an IPC subnet that allows those SPs to act as a single SP, for example, in terms of the services that they provide, and load balance the transactions that are happening and the demand that's coming in for those services. Indexing engines, we've got IPNI, we've got the Interplanetary Network Indexer, right? This is currently decentralized at the protocol level, but there is no good agreement on on the indices. There is no consensus on the indices as far as I know, and also there is no incentivization layer, right? So that's where forming a network that has its own crypto economy would be able to like really bring sustainability to the IPNI indices, and also provide incentives for storage providers to actually, use IPNI because they might, and publish their data to IPNI because they might earn rewards from that act, right? Databases, so things that are running on top of Filecoin as overlay networks and provide different patterns of access to the data that is stored on Filecoin. Quality of service evaluators. We've talked about, I think this is a more general term for kind of like retrieval. I think we've talked this, the retrieval police, or like we've meant like retrieval networks or something like that. It's kind of like this kind of, I think Station, Miroslav is here, is really doing, like pioneering, I think, some of this work. Basically what you want to do is have a fleet of nodes that are watching the network and evaluating and assessing the quality of service of storage providers to then populate a reputational index that then other services, like for example aggregators, can use to make informed decisions of where they place their data on the network, right? So of course, like you want these, why would you use IPC here? You want these probes that are happening and these evaluations that are happening to be coordinated in some manner, right? And to be randomized, but also coordinated, and like, what is it that they're trying to evaluate and why, right? And have a place where, those observations are also posted and rolled up to a reputational score in a provable, verifiable way, right? Retrievability networks as well. So like these are some of the things that I personally think are services that Filecoin needs to really truly materialize the promise of the network and the utility of the network. Cool. So just wanted to talk about a few design goals here of what these networks could look like and what these networks should how these networks should be built from my point of view. First of all, we should target massive scale. This also a slide shamelessly taken from Juan's presentations at PhilDev Summit, I think Singapore and Iceland. He was basically he was analyzing different kind of like the growth perspectives for the storage market, the share that Filecoin can capture of that storage market, and kind of like walking back on what system constraints Filecoin needs to meet and what would be the improvement trajectory to get there. And a lot of these have to do with scale, right? So reads of all size, reads of all of low latencies, storage media for all kinds of types, right? Like a lot of these have to do with networks being able to deliver vast amounts of scale at different angles, right? At different axes. Other design goals, I think, as you think about, I want to kind of like prompt people who are in this room that are designing some of these things these days to consider leaning into Web3 and crypto native networks, architectures and paradigms versus Web 2 or Web 2.5 sort of like hybrid things. Let's just fully lean into Web3. We've got a framework where we can ship custom networks that are going to scale to make these networks happen. I think we should really lean into creating decentralized networks that are open for participation. So finding ways in which storage providers or like other agents can join those networks and start to earn different reward streams based on the new services that they're going to be providing to the network. But also the vast public could be joining and playing a role either through Station by actually running some of the network validation or running some of the probes or running some of the workloads that the network needs, or even delegating staking to, some of the actual validators. They could participate in the network and kind of like the share of the network. I think that all of these networks are going to be highly specialized deployments, and they will contain very highly specialized logic for which IPC is really, and FEM is a really good substrate where you can write your logic in any language that compiles to WASM and ship it as part of the network Of course, we have SDKs for Rust, and there could be SDKs for other languages. We do have some proof of concepts for TinyGo and I think another language there. But like mainly you'd be building those actors in Rust. You can also add custom syscalls to do things that are not usually available to smart contracts. So you could make calls to a file system. You could make calls to a remote resource. Of course, you got to be really careful about that being deterministic, right? Because otherwise you'll have a consensus fault. So those are some things to take into account. And these networks would be secured and driven by cryptoeconomic loops around utility, operativity, and governance. Would integrate natively with Filecoin, with the Filecoin DSN and the L1 network, and would leverage Filecoin's economic security by being rooted on Filecoin. So I just wanted to double click on just two of these because I didn't get time to create fancy diagrams here. I really wanted to illustrate my thoughts, but just didn't have time too much going on. So I'm just going to walk you through some of these ideas of like how you could build two of these networks, and what could be like some ideas that inspire you if you're going to be chasing these with IPC. So for example, if you're going to be building an aggregator, the routing would be on Filecoin, and imagine it's going to be a fleet of subnets. So you start with one, and it's going to grow to as many as you need, depending on the volume that comes in, right? So it would be a horizontally scaled architecture where each aggregator network would be stateless, right? So you're not sharing any state between them because the shared state might be at a parent network, right? So these networks are operating independently. When the throwaway networks, they do some job, they aggregate a piece, and maybe when the piece is aggregated, they can self-destruct, and that's it. If there's no further load to sustain, right? So what's going to be important? You can think of these as kind of like sharded deployments. What's important about this is that we figure out a way to put a load balancer in front of these so that when the user comes in, they don't have to figure out exactly with which subnet they're speaking to, or they don't need to figure out which is the active subnet. They just come in to a single place, and that controller, that load balancer, routes them to the most suitable subnet at that point in time. So you can imagine that payments to aggregators are performed in a custom token. You can call that Agger, for example. And how would it work in terms of the data management? You would be having data coming in, being buffered in the state tree, right? It could be in the state tree. It could be in an offload, in another off-band store that you create a syscall for, and like somehow you somehow you roll up the state of that store into some Merkle proof that you can then factor into consensus, so you get a consistent view over the store, for example. But you would like dump all the data that is coming in that is a candidate for aggregation there. You create some, you might use like some form of Merkle proof, like a mountain range Merkle proof here, for example, to update the tree efficiently as it's coming in, and then roll up to a Merkle root. That's the thing that you're gonna use to provide temporary proofs of custody whenever you're challenged about whether you're really storing this particular piece of data or not, right? So you can accept that piece, and it will live in the network only until the point where a deal. It's saturated a deal enough such that it's feasible to make a deal with a Filecoin network. And at that point, you would flush that deal, you would create the piece, and you would just send it up make it available for fetching from the storage provider by the storage providers from the network. You would just send a command up to some contract in the root chain, which would be Filecoin, right? So that's one idea. Another idea is CDNs. So really lean into the ability of IPC to scale beyond L2s to create a geographical hierarchy that's rooted on Filecoin. So you can have proofs of location required, need to figure out exactly how that is going to be produced. But assuming that we have a proof of location, that could be a prerequisite to join any particular network at a particular point in the hierarchy. You can have global consensus derived from regional consensus at each of these networks. The subnet membership would be gated by proof of location, as I said. And when too much entropy accumulates in a subnet, so you have too much variety in latencies and so on, that would be a trigger point to divide that subnet into 1, 2, or 3, depending on kind of like the partitions or like the groups that you're seeing based on some correlated metric there. Payments would also be used by, would also potentially have their own token, and there could be payment channels that you use to kind of like stream payments as data is being retrieved or routed or like paged into a particular edge location because you are the only person that wanted it there, and you are telling the network that you're gonna want it there for X minutes, X hours, or whatever. That could be part of the metadata in the request between you and the network. And the data would be stored off band, so it might not be stored in the subnet itself because edge nodes and L2s and L3 nodes in a CDN might be holding vast amount of data that is not suitable for actually being part of a state tree. So you might be storing that data off band, and you would just be using the subnets for orchestration, membership, and kind of like the overall topology and organization of the network, and for incentives as well. So I think I've run out of time, as usual. Tends to happen. So I don't know. Do we have time for? Okay, perfect. Yeah. So maybe I'll take a few questions, and if we don't get to your question, I'm gonna be around all day. So feel free to find me in the hallway. Yeah.
A very good point. So on the Fluence implementation, so are you saying their token, FLC token is issued on IPC? Or?
The token is issued on, it lives, and the canonical token is issued on Ethereum, but the subnet is an L2 rooted on Filecoin, and users can move that token atomically from that subnet, from the Ethereum L1 into the subnet in a single transaction using the Axelar bridge. Yeah.
So subnet signed off about
L2s are. L2 for this particular flow, which is take a token that exists in another foreign L1 and bring it into a subnet, into an L2. For this particular interaction, we created the contracts. We could expedite other interactions going forward as well. It just required the logic to do that and the right infrastructure.
Also,
yeah,
petition part.
Yeah,
it's going beyond hierarchical level.
Yeah. So let me just. I think it might be. So that's a really good question. I actually wanted to talk about that. So thanks for bringing it up. You can have a subnet at any given point in time detach from the hierarchy and stop sending checkpoints and stop accepting finality from the parent. What's going to happen is that users can only operate within that subnet, and any interaction that requires sending up a message or making a withdrawal or a deposit is just not going to be queued for later until then the topology reattaches, right? Within a subnet, I think given that we have the ability to create and deploy custom logic now, I think it would be super interesting to have a world in which clients can operate offline by using CRDTs, and they submit transactions in CRDT form, in using CRDT data models and schemes, where the reconciliation then happens on chain, right? So imagine you have a document, right, and you have an IPC subnet, an ephemeral subnet that represents a collaboration session on a document, right? Hypothetical thing. Every edit that you make, if you're offline, right? So I'm maybe using my mobile phone, and I've got an IPC client on my phone that is, currently not connected to the network. I've got a local copy. I make my edits. I save them. I save the deltas and the edits locally. I sign them, right? And when I come online, I flush them all at once, and the actor logic that's running on chain would take care of reconciling or sending me back a conflict that is irreconcilable, right? So that, think about reconciliation of CRDTs on chain. This is not your traditional smart contract DeFi oriented thing. We're talking putting real logic that would usually run on Web2 backends on chain, right? Yeah.
What is there? Be aware anywhere?
No, because at that point, the only thing that needs to be IPC aware is the blockchain client itself and the transaction, submission of a transaction. But the payload, which is the CRDT, you could use any library that exists today and any scheme that exists today to implement that. As long as your reconciliation engine is running can run on WASM, like can be compiled to WASM, and it does not make fancy operating system level calls such that, you know, you would require WASI or something else. Right now, we do not provide WASI compatibility, so you need to be like stay within the WASM sandbox entirely. Yeah, step.
Great. Small trade
True. You could create, yeah.
from was
Exactly. Totally. Yep.
Let's say I am developing one of those functions, maybe the one you went in depth on.
Yeah.
And involved.
Yeah.
Obviously, one big concern would be like trying to figure out exactly the state at which each of the things that you described is like how far down it is.
Yeah, right. Yeah. Totally. Totally. 100%. So we're unfortunately we haven't published it yet. We are working on a feature roadmap, detailed feature roadmap, and like making it public. One thing that I do want to do personally, and I think like Ison and Marco, who are also here from the IBC team, and Longfei and others, I also want to do is like capture input, right, to understand what's important and like have these free flowing conversations, because we do want the first thing that IPC enables. We want it to be the things that have needed to exist on Filecoin for 3 years. Yeah.
Speaking of this function, I guess the question is why can't like why didn't it accurate?
Yeah.
West.
Yeah, true. So if you wanna build Web3 crypto econ native tokenomics, you would need some form of consensus. You would need some ledger, maybe not. I'm like thinking about a world in which you do. And at that point, you would need a framework that allows you to deploy a network that is going to have an account model, a transaction model that is going to be able to deal with, is going to be able to agree and reach consensus on a shared state.
I guess like the best year more around like I could use like I can see where after the walk into it. So more like the old school route and we're like,
yeah.
So how was the on sub L1K all the spirit from L1?
Yep.
I don't do pull ups, worms, what do I get?
Yeah. So you get from IPC, besides kind of like, you know, you could use a state channel. I don't think I don't know how that would work in terms of kind of like the value exchange and the interoperability with other services. So I'm also like thinking about a world in which these services are not independent of each other. If you think about the aggregator, the hot storage layer are two really good examples of services that will need to interact with one another going forward, right? So you can build you can use other tech that does not require a ledger or uses a ledger somewhere else and settles optimistically, but then you kind of like lose the interoperability aspect because you would need to build it from scratch and you need to standardize. So like once you start adding these elements, it kind of like becomes, well, aren't we like building what IPC is, right?
But getting like these teams for fuss.
Yeah.
Like my block text and lights will be.
Yeah. So currently the validation mode that we are considering to be ready is the federated validation mode. So that is proof of authority, right? We do want to, like, it was part of the original roadmap for this current milestone, but we had to descope it because we need to do a lot more hardening, was proof of stake. So having stake, like actual stake deposited and available to be slashed, would be kind of like where the endpoint of where we want to go. Another thing that we're looking at is bringing in ZK proofs as well for correctness of execution, where you can have different levels of usage of ZK proofs. So you could, for example, have all the programs that are running in a subnet be running on ZK EVM or something else, as long as it can be deployed on the FEM. That's something that we could do. Of course, that has performance implications. You could also have specific actors opt in to use ZK EVM, either for like the full actor logic or for particular parts of the actor logic. So you can imagine you have decorators and annotations where you start a critical section and you say this part is going to be ZK proven. Of course, then you have the question of how do you validate the authenticity of the inputs that come into that if they haven't been covered by the ZK execution, but that's a different thing. And then there's also another version of the world where we're looking at at proving only the invariants that need to be maintained in a subnet. Marco, I don't know if there's anything you would like to add here. Yeah.
People, all I remember from IPC is like Sun. And they're like, oh, I heard other project, that stuff that, how would you think like got to the IPC subnet like other?
Yeah. So I think we have if you're specifically using the term subnet, where like our vision of the world and the reason why we use subnets as well is because the internet is driven by subnets, right? It's not kind of like a term that we chose to use, is because a lot of this is a lot of like our thinking is inspired by the architecture of the internet itself, specifically when we talk about partition tolerance and we talk about these deep hierarchies that represent different agents along the tree. So in terms of the term itself, that's like where it comes from. In terms of the model, I think like there's several things that we want to, besides kind of like the high level customizability, the runtime. I'm not sure I've heard any of these projects actually cover ephemeral subnets, and having subnets actually be something that is programmatically created, spun down, has a specific validator policy. And like we're thinking of subnets as really highly dynamic living entities that, of course, like would require a lot of collaboration from the blockchain clients themselves, tooling, explorers. Like you have to think about all these things as well to provide a well-rounded experience to an environment that is highly dynamic. But I haven't seen any other usages of the term subnet actually, go in that direction. Yeah.
More like more absolutely scale. No, I don't see it's important. And it's working.
Yeah. So I think so. One of the things that IBC is capable of doing is IBC is actually chain agnostic. The framework itself is not necessarily bound or coupled in any way to Filecoin. So we could see in the future IBC hierarchies emerging on other chains. And when it comes to interoperability, I think there's several angles there for interoperability. We've got at the basic level, some of these rollups also use Lippy2P. So that's at the networking layer. Of course, that doesn't give you a lot by itself. And in terms of actually, I think IBC, we aim for the project to be highly collaborative with what's out there by truly recognizing the excellent work that has been done in other places. We just have a different way of thinking in terms of what we think that like the mature solutions that are going to provide and cater for this level of scale look like. So I think we would like find ways to integrate with those rollups and Validiums and so on. A lot of those are as well EVM oriented. So the transaction model that we use at IPC as well, we have full EVM Ethereum JSON RPC compatibility, and the transaction model is similar. So there's probably ways in which we can interact and maybe send cross-net transactions and even create bridges that are powered by IPC that connect these other like frameworks, foreign frameworks into IPC itself. There's the hypervisor inspired kind of like architecture of the FEM also lends itself to like mounting some of these runtimes that exist in other chains into IPC. So, that's another angle that would potentially facilitate that interoperability. Something that I think is pretty interesting as well is the IBC, not IPC, but IBC architecture, and specifically when it comes to pairwise communication between chains. Our communication happens over the physical tree right now, but we do envision creating tunnels between subnets, and that could be something that if IBC works, we might actually use or inspire ourselves with IBC and maybe create interoperability layers that allow any IBC hierarchy to actually also interoperate with Cosmos chains down the road.
You see someone is still
Yeah, so maybe I don't think this should be a priority for us. The tech is there if people want to. Exactly. Yeah, I think in terms of where I think IPC still needs to mature to actually be able to really be to be able to compete with whatever is deployed on Ethereum. Um, I think another thing here is the tooling that needs to exist to actually secure a hierarchy and to provide economic security to it, to provide monitoring, explorers, and so on are things that, it's not just about going and deploying the tech, it's about providing the environment in which the tech can be operated and it can be easy to use and so on. So it's like RPCs and so on, and, all this infrastructure that needs to exist, right? Which we are focused on Filecoin. But yeah, the tech is out there. Sorry, I have two questions here. Lauren, do we still have time or?
Start chance because they're still.
Okay, right, yeah. I'm fine to keep going. I'm fine to keep going, 100%. Who wants to go first, Matt, Steph, or? Let you. Yeah. Yep.
I'm thinking about it.
There is also restaking emerging on Filecoin, right? So that might be something that, we decide to use. I think ultimately we do want to ensure that the economic security of the subnets is extremely sound, because they're going to be running critical workloads. So I think when the time comes, we'll assess what the landscape looks like, and we'll figure it out. I think what we do want to make sure that we do provide, and I think Miroslav was here, and I've chatted to him about this just yesterday. It's just been 24 hours. But I think we do want to provide a very easy way for users to be able to run validators and to bootstrap into a particular network and start validating a network in a very light way, simply by downloading the custom logic that is going to be running in that network. I won't go very deep into this, but we do want to provide that ability for anybody, like, to commoditize running a subnet. And we don't want to provide really good UIs to make this happen, right? So imagine like using Filecoin Station, you get kind of like a view, a directory of all the potential subnets that exist that are accepting validators to validate at this point in time. And you get to choose, and you just bootstrap into the subnet, you deposit your collateral, and you get going. Right. And that's.
I've had to give this talk a few times, and I always come back to this same thing about like the way what happens when the subnets attach.
Yep. Yep. Yep.
You might have, it might go down hundreds of layers.
Yep.
All this kind of state, and I guess.
Yep. Yep.
Attached that can make.
Yep.
Is there a point at which the super net, for want of a better word, has to give up or times out, or what happens if?
It could be possible. It could be, yeah. It could be possible. It could be possible. There's no state necessarily to be reconciled here, in terms of like the parent and the child are entirely independent in the state that they actually hold. And like you have to, like, when you build an IPC application and you build a multi-level application, it's really good to think about the data model that is going to be used, and like what's going to live in particular subnets, what's going to live in like maybe the root app like subnet that represents the entire hierarchy. But basically the whole goal is for subnets, when they become detached, to continue operating as normal. They can operate on the local state, and all RPC, like all clients would be able to continue operating without subnet, assuming that the validators are up, because this is the point. They just become detached from the subtree, and this could have happened accidentally, or this could have happened on purpose, because there is a hook that, like, some application logic in the chain that determines that this is a point of detaching, and this might be like an offline session in like a concert for a chat application or something like that, where you don't actually need the connectivity to the rest of the tree. What would happen is that subnet would just park any interactions, external interactions, until it's reattached to the hierarchy. And similarly, any interactions that are going down the hierarchy into the subnet would also get parked. So the moment that they reattach, those interactions would start flowing again.
So non-blocking, but you could have that.
Yeah.
There's still some kind of they can from what there's some reconciliation that does need to happen at that point, right? So, sorry, fine.
I think that the insight, the core insight that might be best set to see here is to segment the state by subnet and not get into state conflicts that way, and do not have to worry about reconciling state. You instead just aren't passing messages yet. So it's kind of like disconnecting your computer from the rest of the internet for a while, and then you reconnect it. And so, sure, there will be a lot of updates that then happen very quickly, and the states advance, but it's not reconciliation of the state that got maybe like changed in different ways. Like there's no double standing.
Yeah.
It's rather like you either had like state in the supernet or in the parent net, state in the subnet, and those are two separate blobs. And like Earl was saying, the messages get like withheld until people get past it.
Yeah.
That way.
Yeah, a lot of this is also like these interactions are, there's no shared state. Each actor in each chain has its own state. So the way that they actually interact with one another is by passing messages. So when you're detached, what you can't do is communicate with each other, but the state can continue to evolve independently. If you have a moment if you have some interaction in the local chain where you depend on like some message arriving from the parent or something like that, and you happen to be detached, then you wouldn't be able to make progress at that point in time because of the dependence that you've explicitly created in your logic, right, of that thing. But yeah.
So you still got to get people created to logic to make sure that they write it optimally to them.
So so IBC does not give you, and no blockchain stack should give you the ability to like automatically create shared state between two different networks. Would be a very dirty model. So you really have to think about message passing, right? And how those interactions are gonna happen. So yeah, it's part of the model. I would say it's not something specific to IBC. It's in general specific to the blockchain ecosystem.
Thank you very much.
Okay. Peace, I guess. What?